Okay, first I want to remind everyone that there is homework set to be due this Friday, but maybe on Wednesday night, I'll check at your school, your grades, and see if we need more time. And we're still in 3.6. And we left off with an example that I'm just going to write down the function after using log rules, and then we'll get the derivative, then we'll do more examples. Okay, we have this. Oh. And yes, the Zoom will be on Canvas tonight. So I'll be sure to post it for sure. Okay, our function can be written as 5 times then I had the ln of 3 to the x, 3 to the power of x. Add ln of cosine of x squared. And then subtract ln of x cubed. And we subtract 5x.
This is 3.5, right?
Yeah, we're in, actually, I think we're in 3.6. Let me check. Yeah, this is 3.6. It's all about logs, or, which includes this guy, ln. Okay, derivative is 5. Okay, here you're gonna have, let's see, I've got 1 over 3 to the x times the derivative, so it's the chain rule. ln, the derivative of ln is 1 over whatever's inside, 1 over 3 to the x. Okay, then go inside, get this derivative, which would be 3 to the x times ln of 3. Okay, that should be good. We're here now. Again, for this ln of whatever's inside, the derivative is 1 over, what's in here, cosine of x squared. Okay, we're going to use a chain rule, go into, just go in here and take the derivative of cosine of x squared, which is going to need another chain rule. Starting with the cosine part, its derivative is going to give you negative sine of what's inside x squared. Okay, go in there and take the derivative of x squared, which would be 2x. then subtract, which will try to make this, wait, okay, it's not the same, it's an x cubed. Let's put it down here. So derivative of the outer function, ln, will give you 1 over what's inside, 1 over x cubed. And go inside, take the derivative of x cubed, which is 3x squared. And now we're at the end with derivative of 5x being 5. So subtract 5. Okay, so I simplify this and I have 5 times ln of 3. So I have those 3 to the x is reduced to 1. Plus negative tangent of x squared times 2x, which I'm going to put in the front.
Where did sine x squared times 2x come from, by the way?
Oh, the chain rule. So you go here and get that derivative, go inside to get that derivative, and go further inside to get that derivative. So it's from using the chain rule right here.
Oh, okay. Yeah. Oh yeah. I did what's in cos.
Yeah, and then
Yeah, because you did what's inside cos. Yeah, chain rule. Okay. Yeah.
okay, and then I got this tangent of x squared. Okay, and then subtract 3 over x and subtract 5. Okay. We are going to go over steps to how you could get the derivative of a function with an exponent that is also a function. So let's say you have something that looks like this. Okay, so it's log differentiation or logarithmic differentiation. It's for functions y that look like some function f of x. And it has an exponent that is also a function. We're going to call it g of x. So we'll talk about how you could get the derivative of something that looks like this. we start with getting the natural log of both sides. Let's see. Let me say that better. So we talked earlier this semester about how if it's a function, every input has one output. So if you have equal inputs, you'll have equal outputs, which means if we've got, let's see, this equal to this, we'll send, or like we'll have like, how do we do this? We'll send two equal values through the function ln of x, and they'll have equal outputs. So I guess that's like the precise way to say what we're doing, but I guess a shorthand is just take the natural log of both sides. But what we're actually doing is sending two equal inputs through the natural log function, and we're getting equal outputs because it's a function. Anyway. And then before I go over step 2, so let's say we ln both sides. By doing that, we can use that exponent rule we talked about yesterday and bring that function up in this exponent down and multiply it with ln of that f of x, which we'll practice in a bit. Simplify as much as possible using log rules. Okay. Then you can, let's see, take the derivative implicitly or use implicit differentiation like we did last section. And then after that, we will isolate y prime. So for step 3, take the derivative implicitly. And then I have a note. So we should have something that kind of looks like the derivative with respect to x of ln of y and that will give us, oh, and also you have to remember y is a function. So we're using the chain rule and taking the derivative of the outer part, which is the ln part. So we'll have 1 over y. And then go inside and get the derivative of the function inside, which we'll write as y prime. Multiply that with that 1 over y. Again, that's from the chain rule. Okay, and then for step 4, you isolate y prime. Or you're looking for dy dx or your y prime. So what you do is then multiply both sides by y and then sub in what y is actually equal to. So that your variable in the end is all x. It's like the, yeah, the only variable in your final answer will be that x variable or whatever your input variable is. Great. So we're going to practice a few of these. Starting with y being equal to x with the power of sine of x. And we'll get y prime. Okay, so I'm just going to start with writing down the problem. Y is x with the power of sine of x. So that first step, the idea is if this side is equal to that side, you have equal inputs and put them both through the function ln, and you'll get equal outputs. So we'll have ln of y equal to ln of x with the power of sine of x. Okay, next we're going to use log rules and bring that power down, multiply it with ln of x. Okay, so now we're going to take the derivative. We're going to use implicit differentiation. And again, remember, y is a function.
Wait, what? Wait, how did come the sine x? Where did the sine x exponent fell? The sine, it's an exponent, but now it's like a full. Now it's like a whole number. Now, what happened?
I'll write the rule on the side.
Oh,
It is
sorry.
the power rule for the ln function. So if you have,
Oh,
yeah, it's,
use the power rule. So like, oh, the power rule.
I
So
was
like,
like,
you know how like
yeah.
you -1.
No, that's the power rule for
Wait, but
derivatives. I'm talking about a power rule for logs. So I'll write that on the side.
oh,
Yeah.
yeah.
Log. We talked about it being like ln of x to the r. That's what we said. Is r times ln of x. So this is a rule for logs. And if you have a power up here, you can bring it down and multiply it with whatever that base, ln of that base of that number with an exponent. Okay. So anyway, we have like a cosine of x right here. You can bring it down and have, or a sine of x. That sine of x can come down and multiply with ln of x. So we're over here taking the derivative. On this side, you start with the outer function ln. So you have a 1 over y for your derivative. And then use the chain rule, go in here, get the derivative of the inner function, which you don't know what that function is. So we'll write it as just some y prime. Or actually, we do know what it is, but we can just write it as y prime. Okay, there we go. And all right, equal to. We're going to need a product rule right here. Okay, I'm going to call this part F and this part G. And we're using F prime G plus G prime F. So derivative of sine would be cosine of x.
Wait, what happened to ln(y)? Because ln(y) is like it became 1 over y times the derivative of y. Where did that come from?
Well, I mean, yeah, actually, true. I'm going to recopy this down. And this comes from getting the derivative of both sides, or implicit differentiation. So this side, that derivative gave us the 1 over y times y prime. Okay, on the other side, we started to get the derivative. It would be cosine of x times ln of x plus. All right, derivative of ln of x is 1 over x. And then times that sine of x. Okay, next, multiply both sides by y. Okay, so that way this y and that y will reduce and leave the y prime that we're looking for. And then on this side, we want the variable over here to all be x. So we'll replace that y with what we were given in the beginning. Y was x with power sine of x. So we've gotten 2 y prime on this side times cosine of x, ln of x, equal to cosine of x times ln of x. Plus sine of x over x. And it's all multiplied by x with the power of sine of x. So again, you want to substitute the y that you're given in the beginning and have the variables in your answer all the same. And that's the answer, by the way.
Yeah, see, I'm still kind of confused. I'm still trying to figure out how you get the 1 over y from, how did y become 1 over y times y prime? Is there like a rule for that?
It's because y is a function. So maybe we'll do a quick example on the side and hopefully that helps, but
You could erase the product rule, yeah, thing, and then you could just like write how that happens.
okay, let's say like right now you don't, well, you do know what y is. I'm still gonna make a little example. Okay, let's do we'll do like 2x cubed. And we'll call g of x ln of 2x cubed, ln of y. Of x. Okay, so get the derivative of that function g. So you start with the outer function ln of x. Getting that derivative would give you 1 over the 2x cubed. So let's do this. Okay, and then you get the derivative of the inner function, which would be 6x squared, and then multiply it with that.
Oh wait, I think I see what you did there. So you just did so you kind of did the chain rule with ny, and when you try to inverse the y, that y just becomes y prime, right?
Yeah, like because it's just easier to write down.
Okay, yeah, I think I see what you did there. That kind of explains it.
Okay, we're gonna go into another example, and I think practice also helps. Okay, y is the square root of 2 to the x times tangent of 5x. over x cubed times e to a power of 2x. And we'll get the derivative, y prime. Okay, so I think what's going on is if I rewrite the root as a 1/2 power, and then go through the steps, we could get that y prime. Y is, when you have a root, it's a square root. And the root is always in the denominator of your power. So we're going to go here, the 1/2 power. And inside is the 2 to the x, tangent of 5x. So over x cubed times e with power 2x. So we have,
Wait,
yeah.
square roots, you put the 2 there. That means same thing as a normal root, right?
Like if this, let's say this was a cubed root, so you'd have a 1/3 power.
Oh.
If it was like a 5th root, it'd be a 1/3.
Yeah.
Yeah.
Yeah. Yeah.
So you're going to take the natural log of both sides, or we'll send these equal inputs through the natural log function and get equal outputs. Ln of y would be equal to ln of all of this. And we're going to go ahead and use a power rule for logs right away and bring that 1/2 down. Multiply it with ln of all of this. Okay, and then we're going to keep on working with log rules on this side before we do any differentiation. So the first log rule I want to use is for this division right here. We'll take the log of what's in the numerator and subtract the log of what's in the denominator. And then don't forget this 1/2 that's multiplied out. Okay, so from here, we're going to do the next step at the top of the board. Let's copy down this side, ln of y. It's equal to 1/2 times. Okay, we got an ln of 2 to the x times tangent of 5x. Minus ln of x cubed times e to the 2x. Okay, and then more log rules. We've got one for the product, and also there's another product here. So we'll just keep expanding.
Wait, is there supposed to be like a quoted rule? that you do for like the fraction?
Yeah, I guess
Remember?
quotient rule for logs, that's where that subtraction comes from. And the
But
product rule for logs, we're
okay.
gonna change from multiplication in the log to addition outside of the log.
Okay.
Okay, so this one here would give us ln of 2 to the x plus ln of tangent of 5x. Okay. And here we're going to subtract, which I think I'm going to put down below. Okay, subtracting ln of x cubed plus ln of e to the power 2x. And you want to subtract all of that, so I'm going to put it in parentheses. Okay, and then we're going to distribute that negative sign. Also kind of simplify like this part here for sure. And then we'll start to find the derivative, or we'll use implicit differentiation to get y prime. Okay, let's try writing it here.
When it comes to doing derivative, is just like some kind of orders of operation thing happening, by the way?
I don't think so. Just wanting to follow all the rules for derivatives, but they don't have to be done in a certain order. So I think maybe like, you know, the chain rule, I would say you want to start with that outer function and go in. All right, we're still just doing log rules though. And I've got, well, we did all the log rules. We're just kind of rewriting this a little bit. And then I'll find y prime. Okay, 1/2 times, let's see, let me see how I wrote this. So it could be I did. I was like, we could use a power rule here. And we will. We're going to bring this x down, multiply it with ln of 2. So x times ln of 2. And then the next term is ln of tangent of 5x. Okay, we're going to subtract 3 ln of x. And you're going to subtract ln of e to the power 2x, which is going to leave 2x. So subtract 2x at the end. Okay.
Wait, why does tan stay the same?
There's no rule that I know of really for like trig functions and log functions. Like there's also no power or anything to change. It's just
Yeah, I guess.
simplified at this point.
Like, can you just turn the 5 into, wait, can you turn the 5 into like just a 5 though? By using power rule or not?
No, you'd have to have that x up in the power, but it's 5 times x, not 5 2 of the x. So,
Okay.
since there's no power, we're not going to use any power rule for logs. Let's see. we're getting the derivative of both sides. On this side, the derivative of that outer function, ln, is 1 over what its input is, which is y. So we've got 1 over y, but y is a function, so you use the chain rule, go in here and get the derivative of y, but we're going to write it as just y prime. And then taking the derivative of this side, we've got this 1/2 times. Ooh, cool. So ln of 2 is some number. So you've got x times number, and the derivative of that would be that number, ln of 2. Okay, plus. Sorry about that. All right, for this one, we're going to use a chain rule. First with that ln function on the outside, then go into this tangent function and go even further to this 5x all the way in there. Okay, starting out here with derivative of ln of this stuff is 1 over that stuff. 1 over tangent of 5x. Okay, then go in through these parentheses, take the derivative of tangent of 5x, which would be secant squared of 5x. Okay, and you gotta go even further in and multiply with the derivative of 5x, which would be 5. Okay, minus the derivative of 3 times ln of x, which would be 3 times 1 over x. So subtract 3 over x. And the derivative of this last piece would leave -2, or we're going to subtract 2 at the end. Okay, let's try to simplify this. And we need to multiply both sides by y, so that over here we have y prime, and over here,
Where do you get the 5 minus from?
oh, that 5 comes from this derivative of the 5x function all the way with the chain rule.
Oh, okay, I think I see, yeah.
Okay, let's multiply both sides by y and also maybe simplify this a little bit. Okay, so when I multiply this side by y, the y times 1 over y reduces and leaves y prime. So I've got my y prime. On this side, I multiply this side by y. And then there's the 1/2, which we'll just copy down. And then inside here is ln of 2. Plus secant squared of 5x over tangent of 5x. Oh, times 5. That doesn't look so awesome. Subtracting 3 over x and 2. Okay, the last thing we need to do is replace that y with that whole square root that it was equal to. And also, I think I used some trig identities, or, just simplify this little trig part here, since they both have a 5x as their input. And let's see if we can fit all of this on the whiteboard. Okay, so here's my y, which is the root of 2 to the x times tangent of 5x over x cubed times e to the 2x. Okay, so we got that root, multiply it with the 1/2, and then inside is that ln of 2. And then I simplified the secant squared of 5x over the tangent of 5x as 5 over sine of x times cosine of x. So you can leave it like this, or you can try like doing that scratch work at another time to just check, check that part if you want to. Anyway, I just wrote to simplify this as sine of 5x times cosine of 5x. Okay, we're almost done. Okay, you subtract the 3 over x and you subtract the 2, and then that's our answer, which I'm just going to extend this. If you're writing this on paper, I would suggest you just continue going this way, but I've run out of room and we have 2 more terms to subtract, that 3 over x and a 2. Okay, that's your answer. Y prime is y, but substitute what y is equal to, multiply with 1/2. We got this. And I just want to, so I'm gonna let you go. I know we've run out of time, but I want to say we finished 3.6.
Wait, so when do we sub in y or not?
For solving with log rules, definitely always substitute y back in at the very end. So always. Or like when you want to put your answer in, be sure that the variables are all the same. So all in that variable x and not x's and y's. You just want.
Okay, that's nice to know. Have a nice day, Cassie.
Okay, well, last note too, just we finished 3.6. Next time we're going to start 3.11, and then after 3.11, we're going to get into chapter 4.